Okay, let's talk about the mechanism of breathing. So what you have to link it to when you talk about how we breathe is how we can manipulate the pressure inside our chest cavity. And our chest cavity is everything that's inside our rib cage. So it's the lungs, the heart's in there as well, but we're going to focus on how we can manipulate pressure in the region that's inside the rib cage and how that can cause air to go into the lungs. Here's something you might have seen in like year 7. It's like a bit of a magic trick where there's a tube going into what's called a bell jar with a bung at the top. So the only way that air can get in is through the top. The bottom is sealed as well. It's sealed with some sort of latex. And that latex, if you pull it down, it causes the balloons to get bigger. So without touching the balloons or without blowing into this tube, you can make these balloons get bigger. And how that's occurring is by pulling this latex material down, you are making the volume inside this gas jar bigger. And if you increase volume, you decrease pressure. And therefore, if there's a lower pressure inside this jar compared to outside, that's going to cause air to rush in. And that's how vacuum cleaners work. A vacuum cleaner, it creates a low pressure inside the machine, which causes air to get sucked in. If you want the balloons to get smaller, you push the latex up into the bell jar. You are decreasing the volume and therefore increasing the pressure. So it's the same with how a syringe works. If you put this syringe here into here we go. If you put this syringe into like a beaker of water and you want to get the water out, you need to pull this handle up. So if you pull that handle up, what you do to the volume, you are increasing the volume, and therefore by doing that, it's an inverse relationship with pressure. You decrease pressure, and by decreasing pressure, you are causing a pressure difference, and therefore a suction occurs. And if I want to get the water out of here, I push this handle down, and I push the handle down, I'm decreasing the volume, and then I'm increasing the pressure. So this inverse relationship, this is exactly how we breathe. So this, you might have guessed, this latex is kind of representing the diaphragm. At the bottom of our chest cavity, we have a muscle called the diaphragm, and this diaphragm can move up and down. So when it moves down, that's going to cause the chest cavity or the thorax region to increase in volume. We've also got another way of making our chest bigger, and that's to make our rib cage go up and out. And you could do this now if you just take a big deep breath. You'll feel your chest getting bigger and going up. Try and take a deep breath without moving your chest. It's impossible. So it's the only way you can breathe in is by making your chest bigger. So I want to just talk about how our muscle contractions can cause us to do something equivalent to a syringe or this bell jar. So here we go. When you want to breathe in, well, we need to make sure that the pressure inside this chest cavity is low. How are we going to make the pressure low? We need to make the volume bigger. So to make the volume bigger, our diaphragm, which is a muscle at the bottom of our chest cavity, we need that to contract and pull down. So that's going to make the bottom part of the chest cavity increase in volume. We also need another muscle contraction to occur. We've got something called external intercostal muscles, and these muscles are responsible for contracting and pulling the rib cage up and out. So we've got a downward movement of the diaphragm, and we've got the ribs, it's not that far, moving up and outwards. So that combines contractions of the diaphragm and the external intercostal muscles have caused increased volume and therefore decreased pressure. And that is going to cause air to move in. So it's the exact opposite then. If we want to breathe out, we need to make the volume in here smaller. We need to decrease the volume and we need to increase, and that's going to cause an increase in the pressure. So how do we decrease the volume? The diaphragm now, a muscle, it relaxes, and the diaphragm's natural position is to be in this like a curved shape, so it naturally pushes up. That's going to decrease the volume of the lower part of the chest cavity. The external intercostal muscles, they're going to relax, but the antagonistic muscles that work against them are the internal intercostal muscles. They're going to contract and they're going to pull the rib cage down and in this time. So suddenly now the chest cavity is looking much smaller in volume. Low volume is going to increase pressure. That's going to force air out of this person. That is the same as pushing this handle down to force the water out, or pushing this latex up. All right, so just so we can, quick summary, I'll just go through how we inhale, and maybe at the end of this video you could use this as a writing frame to describe how we exhale. So to inhale, the diaphragm contracts and moves down. External intercostal muscles, that's spelled wrong, it should be an N there. External intercostal muscles contract and move rib cage upwards and outwards. This causes the thorax volume to increase and the pressure in the thorax to decrease, and therefore air moves into the lungs from an area of high pressure, which is outside the body, to where there's a lower pressure inside the lungs, because that is where they're found, inside the chest cavity.